Okay, so this is problem number 8 on the chapter 4 homework on page 109. So the first thing I did was obviously find the positive y and the positive x direction, and then I drew a diagram. So we know that the bullet is 5 grams and it has the normal force acting on it, its weight pulling it down, and an unknown force, this is why it's x, and a negligible force of friction or air resistance or whatever you want to call it. So the reason why this is a hard problem is because we first need to use a kinematic equation to find the object's acceleration before we find the force pushing up on it. So first thing we need to do is plug in the values. So we know that the final velocity is 320 meters per second. So 320 meters per second squared. And we know that it started from rest, so its initial velocity would be 0 meters per second squared. And then plus 2, we don't know the acceleration. And we know the length of the barrel of the gun, which is 0.82 meters. 0.82 meters. Okay, so what we can do now is just continue solving. So this would be 10240 meters squared per second squared, and because this is 0, this would not account for anything, and that would be 1.64 m times the acceleration. So now we can just put that in our calculator, and we will get 62439.024. Okay. And then the next thing we have to do is using this knowledge of the acceleration, we can now plug it into F equals ma. So we want to know the force, and we know the force is x, our unknown force, minus the force of friction or air resistance, which is negligible. So this can be just counted as 0. So basically the force is x. And so all we need to account for is this particular force, because this is negligible. If it were supposed to be taken into account, there would be a friction coefficient. So now that we know that all we're doing is solving for the force in this direction, we can easily say that because f of x equals mass times acceleration of x, we can just replace f of x with x, or the force required to push the bullet this way. So x equals mass acceleration of x. Okay, so we don't know x. We do know the mass of the bullet, which is 0.005 kilograms, and we know the acceleration, 62439.02439 meters per second squared. Now keep in mind that whenever you're multiplying kilograms and meters per second squared, it is always going to have a result in newtons. So once you multiply that up, you will get the result of 312.2 newtons. And that is your final answer.